sorted set. You will get it ascending order. You observe. You will get it ascending order. Java C demo.java. Java demo. See, ascending order. But how we are getting ascending order, I'll explain. Write this example. Or now, how it will be sorted set comes, I'll show you. You already studied yesterday tree set. It is an implementation of which class, which data structure? Red black tree. Red black tree is similar to binary search tree. In a binary search tree, if the element is less than left side, element is greater than right side. If element is same, automatically rejected. It does not allow duplicate. Okay. Now, suppose first 84. Now, here 84. First ts dot add 84. 84 added. Ts dot add 55. It is less than 84. So left side. It is less than 84. So left side. 55 left side. Ts dot add 92. 84, 92 compared. greater than right side. So 92. Like this. Now 90. First
Recording
T
in
is
progress.
drawn at 24. It is less than left side. Again less than left side. T is drawn at 99. It is greater than right side. Again greater than right side. Like this. Then you observe. So you are getting sorted. No? Ascending order comes. No. See 24, 55, 84, 90, 92, 99. This is ascending order coming. Ready, son? 24, 55, 84, 90, 92, 99. Ascending order comes. It is automatically sorted. With the binary search tree technique, it is sorted like. Is it completed? No. With the binary search tree, complete. Sorted. This is about tree set. Next, write it. The hierarchy of set implementation classes. The hierarchy of set implementation classes. Object, abstract collection, abstract set, asset, linked asset, reset. object, abstract collection, abstract set, hash set, linked asset, tree set. Object, abstract collection, abstract set, hash set, linked asset, tree set. Over. Using linked asset object, can I call hash set methods? Using hash set object, can I call linked asset methods? No. Linked asset object, can I assign to object class? Abstract set object, can I assign to tree set? No. Downcasting. So this concept is for upcasting, downcasting purpose, this is required. Methods purpose, this is required. The method is not available here. Next, superclass. Again, superclass. Again, superclass, like that. Okay? That purpose, this is required. Now, next one, hash map. Note? Hash map. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. See, you studied about hash set. You studied about hash set. Hash set, hash map, same. That is one dimensional. This is two dimensional. Okay. It is an implementation of hashing technique with array representation. Hashing already studied. No? What is hashing? It is the technique in which insertion, deletion, find, three operations in a constant average time. Almost same time it will take. For three operations in a hash set, same time it will take. That is hashing. Representation method array. So array style it will represent. Next node. It maintains data. It maintains data as a key value pairs because it implements map interface. It maintains data as a key value pairs because it implements map interface. It maintains data as a key value pairs because it implements map interface. It maintains data as a key value pairs because it implements map interface. Next node. It does not allow duplicate keys and it allows duplicate values. It does not allow duplicate keys and it allows duplicate values. It allows one null key and many null values. It allows one null key and many null values. Why only one null key? Duplicate not allowed, no? That is the reason. Two null keys not valid. It allows one null key and many null values. It supports both homogeneous elements, both homogeneous key value pairs and heterogeneous It supports both homogeneous key value pairs and heterogeneous key value pairs. Default initial capacity. Here default initial capacity is 16. Here default load factor is 75%. Your default initial capacity is 16. Your default load factor is 75%. It supports both homogeneous key value pairs and heterogeneous key value pairs. Your default initial capacity is 16. Your default load factor is 75%. Okay. Whatever you studied about hash set, same concepts here. About hash set you studied, no? About hash set, whatever you studied, here also same concept. But only difference, one dimensional, it is two dimensional. That is here insertion order is preserved or not preserved? Insertion order is preserved or not preserved? Hash set you studied, no? Not preserved. Linked hash set preserved. Here insertion order is not preserved. It is an unordered map. It is an unordered map. Here insertion order is not preserved. It is an unordered map. Is it over? Here insertion order is not preserved. It is an unordered map. See, technique is hashing technique, representation, array representation, key value pairs maintained because map. Okay. Duplicate keys not allowed. Duplicate values allowed. One null key, many null values. Homogeneous, heterogeneous, both. Initial capacity 16. Load factor 75%. Here insertion order is not preserved. It is an unordered map. Now these all points remember. Okay. How to implement this one, you observe. Here writing programs are nothing. Concepts are important. See, hash map. Now HM equal to new hash map. It is key value pairs. Key which type? Suppose integer. Value which type? String. So employee number, name. Like this you can maintain. Suppose employee number, salary. Like this you can maintain. Otherwise, employee number, employee name and salary. Like this you can maintain. Okay. Now, employee number, name. Employee number, salary. Employee name, salary. Okay. Now, online students, end of the session, I'll clarify your doubts. Listen the class. Now, here, employee name and salary. Employee number, name you can write. Employee name, salary you can write. Employee name, employee number, name. Employee number, salary. Employee name, salary. Whatever you want, you can write. But this is a key. This is a value. It is duplicate not allowed. It is duplicate allowed. Here one null key allowed. Here many null values allowed. Okay. But here method name put method is there. Put. Okay. One dimensional add method is there. Two dimensional put method is there. Say Java P Java dot util dot hash map. Hash map here add method not there. Put method is there. K comma V while creating whatever you write that type. Suppose here something James Gosling. Okay. Java developer name James Gosling. Name I written. Here some salary. Okay. Some salary I'll write. Now like this. Here employee name I given. Here employee salary I given. Okay. Employee salary given. Now hm dot put one more employee name. Java developer names only. Okay. Now hm dot put Ed Frank. hm dot put okay. hm dot put. These 5 members Java developer names I written. System dot out dot println hm. Now first I given James Gosling, next I given Patrick Norton, next I given Ed Frank, next Cherise Worth and Mike Sheridan. 5 members team, the people names I given. File save. Can you predict the output? Output we cannot predict. That is unordered map. Say compiled successfully executed. So first what is came? Patrick Norton. In my system, first what I given? First program. So it is not my order. Is it alphabetical order? No. If it is alphabetical order, first C comes. This one. Okay. Here Ed Frank. Next like that. It is not alphabetical order. It is not my order. It is not alphabetical order. It is hashing order. So what will happen? First P, C, E, these all complete. Like ASCII code percentile 16, modulo division 16. Reminder which comes no, that place inserted. Yesterday I was shown hashing algorithm like that type. Write this program. Output you cannot predict. Example, note down. Is it over? So output cannot be predicted because it is an unordered map. Output cannot be predicted because it is an unordered map. Output cannot be predicted because it is an unordered map. Output cannot be predicted because it is an unordered map. Is it over? Next one, linked hash map. Linked hash map. It is an implementation of hashing technique with linked representation. Remaining points, same points note on. It is an implementation of hashing technique with linked representation. It maintains data as a key value pairs because it implements map interface. It does not allow duplicate keys and it allows duplicate values. It allows one null key and many null values. Same. Uh, it is same. It supports both homogeneous key value pairs and heterogeneous key value pairs. Your default initial capacity is 16. Your default load factor is 75%. Same concept. Your insertion order is preserved. It is an ordered map. It occupies less memory or more memory? More memory, because node representation. Okay. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. So writing program is nothing. Remember these points. Okay. Is it over? So here insertion order is preserved. It is an ordered map. It occupies more memory because data is stored in nodes. Now, same program, I'll make it linked hash map. Just you observe. Linked hash map. Here, linked hash map. This reference name, same also you can write. Different also you can write. Now, if I write like this, file, save, it is ordered map. My order comes as it is. See, compilation, execution. See, my order: James Gosling, Patrick Norton, Ed Frank, Cherise Ward, Mike Sheridan. Okay, write this one. Write this program. So linked hash map, it is an ordered map. Same output comes. Is it over? Now, what is output comes? Same order comes. Okay. Next one, tree map. Next node, tree map. It is an implementation of, you can give answer possible. Red, black tree. Red, black tree technique with linked representation. Node? It maintains data as a key value pairs because it implements map interface. It does not allow duplicate keys and it allows duplicate values. Here, it does not allow null key. It does not allow null key and allows null values. It does not allow null key and it allows null values. Tree map. It is an implementation of red black tree technique with linked representation. It maintains data as a key value pairs because it implements map interface. It does not allow duplicate keys and it allows duplicate values. It does not allow null key and it allows null values. It supports heterogeneous key value pairs only. Homogeneous key value pairs only. It does not support heterogeneous key value pairs. Here default initial capacity is 0. Insertion order is not preserved. It is a sorted map. it occupies more memory because data stored in nodes. See, writing program is nothing here. These all points you have to remember. It is important. Is it over? If I execute this program, what will be the output comes? First, which one comes? First one, Shri's Worth. C. Shri's Worth. Next, Ed Frank. Next, James Gosling. Next, Mike Sheridan. Next, Patrick Norton. Alphabetical order. Alphabetical order. See, first, Shri's Worth, Ed Frank, James Gosling, Mike Sheridan, Patrick Norton. Okay. So here, what you written, it is a sorted map. Okay. Here, note on. Here, key value pairs are sorted based on keys. Here, key value pairs are sorted based on keys. Here, key value pairs are sorted based on keys. Okay. Here, while sorting, what will happen? This value with this key only will be there. If keys sorted, values sorted means what will happen? This person salary, this will become. So first this person salary, it will become this one. Next person salary, it will become this one. Salary is changed. Okay, that will happen. It is one pair. In that pair, key only considered to sort. Values are not sorted. Key association value with that only will be there. Write this program. So first Shrisworth, next Ed Frank, next James Gosling, next Mike Sheridan, last Patrick Norton. Key value pairs are sorted based on keys. Key value pairs are sorted based on keys. Is it completed? Now I'll ask some questions, give me answer. Next, then we'll see next. These 10 classes, how many completed? 8 completed. Now, will it allow duplicates? Yes. Second one? Third one? No. Fourth one? No. Fifth one? No. Sixth one, will it allow duplicate key? No. Here? Duplicate key? No. Here? No. Okay. Duplicate values allowed. Duplicate keys not allowed. Now, will it allow null? Yes. Will it allow null? Yes. Will it allow null? It will allow. Will it allow null? Yes. Will it allow? No. Tree set will not allow null. Hash map, null key, allowed. Null values, allowed. One null key, many null values. Here one null key, many null values. But here, null key not allowed. Null values allowed. So, tree set will not allow null key. Tree map will not allow null key. Will it supports homogeneous, heterogeneous? This one, second one, third one, fourth one, fifth one? No. Heterogeneous not allowed. Sixth one, seventh one, eighth one? No. Heterogeneous not allowed. Same type required. Okay. Initial capacity 10. Year 0. Year 16. Year 16. 0. 16. 16. 0. Okay. Load factor 100%. Year no load factor, because 0 means no load factor. Year 75%. Year no load factor. Year no load factor. Okay. Is it array representation or linked representation? This one, array. This one, representation. Array or linked? Array or linked? Linked. It is linked. It is array. This is linked. This is linked. These are linked only. Name is linked tree set, not there, but linked only. Here, which data structure? Linear list. It is double linked list. Here, hashing. Here, hashing. Here, red black tree. Here, hashing. Here, hashing. Here, red black tree. Okay. Insertion order. preserved. Here, preserved. Here, not preserved. Here, preserved. Not preserved. Not preserved. Here, preserved. Here, not preserved. Okay. These points only they'll ask in an interview. Okay. You have to remember. Next, the hierarchy of map implementation classes. The hierarchy of map implementation classes. The hierarchy of map implementation classes. Object. Abstract collection. Oh, sorry. Abstract map. Abstract collection are there here. Abstract map. Here. Hash map. Tree map. Linked hash map. You ready, son? Object, abstract map, hash map, linked hash map, tree map. Is it over? Now, linked hash here, you observe previous all collections derived from abstract collection, but these all abstract map. It is two-dimensional collections hierarchy. Okay. Next, difference also I didn't explain. Nodal. Differences between hash set, linked hash set, and tree set. These also you have to write. Difference between hash map, linked hash map, tree map also you have to write. First write this one. This I didn't give before this. Write this one also. Differences between hash set, linked hash set, and tree set. These three sets difference also I didn't give you. That's what I'm giving. Array list, linked list difference I given. Differences between hash set, linked hash set, and tree set. Now, hash set, linked hash set, tree set. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. Otherwise, red black tree you can write. Binary search tree, red black tree, both are same. Similar, little bit different. It occupies less memory. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. As said, linked as said, tree said. It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with linked representation. It is an implementation of binary search tree technique with linked representation. Otherwise, red black tree, you can write. It occupies less memory. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. This class name tree said, but representation method is linked only. Linked only. That is the reason more memory. Here, one is array representation as said, one is linked representation as said. But tree said array representation not there. They prepared only linked. They prepared only linked. Okay. Now, it is ordered, unordered, or sorted. It is an unordered set. It is an ordered set. It is sorted set. It is a sorted set. It is an unordered set. It is an ordered set. It is a sorted set. Okay. Here insertion order preserved or not preserved? Here insertion order is not preserved. Okay. Here also, here preserved. Here insertion order is preserved. Here insertion order is not preserved because sorted. Here insertion order is not preserved. Here insertion order is preserved. Here insertion order is not preserved. Here insertion order is not preserved. Here preserved. Here not preserved. Is it over? Fifth one. Will it allow null value? It allows null value. It allows null value. It does not allow. It does not allow null value. It allows null value. It allows null value. It does not allow null value. Okay. Sixth one. Say default initial capacity. Here default initial capacity is 16. Here also 16. Here default initial capacity is 16. Here default initial capacity is 0. Here default initial capacity is 16. Here default initial capacity is 16. Here default initial capacity is 0. These are the differences between hash set, linked hash set, tree set. Okay. We'll see continuation tomorrow. So collections, multi-threading need new features. All are important only. Up to last class important only. Okay.